The most advanced radiofrequency ablation system developed to treat cardiac arrhythmias is being used as a frontline therapy at Texas Cardiac Arrhythmia Institute in Austin. This helps reduce complications and increase patient safety and improve outcomes. The QDOT system uses microelectrodes on the tip of the catheter to better delineate scar in the mapping system to enable more pinpoint ablations. The integration of microthermocouple technology also provides a true view of the temperature during energy delivery and the angle of the catheter tissue contact. This helps reduce the chances of dangerous steam puffs. The therapy also allows more energy to be transferred into the tissue to create effective lesions faster. It also allows for higher energy ablation for shorter durations of time, thus leading to shorter, more economical procedures. Dr. Andrea Natale, Executive Medical Director of the Texas Cardiac Arrhythmia Institute and National Medical Director of Cardiac Electrophysiology for HCA Healthcare, and Dr. Rodney Horton, researcher at the Texas Cardiac Arrhythmia Institute, and explain why they feel it's a game changer to improve care for patients who need RF ablation procedures.
Every time we try a new technology, we go through a process of learning in how to optimize the best feature. But it was very obvious that the procedure was more efficient. The working parameter really prevent, for the most part, steam pops. So if you try to skip the contact force law, we virtually don't see steam pop anymore. It's extremely unusual. So that really drive the safety quite a bit. Also, for the people who worry about esophagus and are not willing to move it or cool it, the 90 watts for 4 seconds create more superficial lesion that doesn't reach the depth that is required to worry about nasal esophageal fistula. So that's another option that people can choose.
When it first came out, I was a little bit skeptical. So I had tried it in non-clinical settings, in bench testing and things like that. And it looked interesting. I kind of liked the fact that you could sort of see the temperature and the catheter temperature real time, but I wasn't sure it would actually translate into anything. And it was really after about a week of using it that I realized that it was a pretty big advantage because the catheters would move in a very predictable way. The lesions would go away, or the lesions would form and the signals would go away in a very predictable way. I think that it dramatically improved the efficacy and the timing of these procedures to me, as well as safety.
There are two options. One, you can go to 90 watts for 4 seconds, or you can drive to a maximum of 50 watts based on tissue temperature.
It took all of the things that had been iterated in the past, and then we were able to measure direct temperatures. Plus, you could use high power for very short duration lesions, and looking at it from a biophysics standpoint, that will generally cause you to have a much shallower lesion. So if you want an area and you only want to ablate a very 2 millimeters or 3 millimeters of depth, you can sort of dial it in that way, whereas you couldn't really do that with the prior technologies. If you don't ablate deep enough, it won't work, right? So you're kind of wasting your time and wasting the patient's time. If you go too deep, then you could potentially have collateral damage. And so it's a balancing act between efficacy and safety. And then that's where a lot of these, that's where open irrigation made a big difference. That's where contact force made a big difference. And that's where I think this has made a big difference. Tailoring the workflow to the different ways and different modes which it can be applied really is depending on, so if, for example, if you're trying to ablate on the posterior wall and you know for sure that anatomically that's where the esophagus is, and if you're using intracardiac echo or something like that, you can actually see how close you are to the esophagus. You know that that tissue is thin. You don't want to go beyond that, and so the shorter you apply the lesions, the shallower the lesion will be, and the less likelihood of doing this. So this is the way of prescribing how you adjust this, and a lot of people do this. They'll ablate with different power settings and different force settings and targets, depending on what part of the heart they're ablating. There's some areas that we know for sure are very thick, and so we would do the opposite with those to try and get deeper lesions.
Even from a point of fluid administration, one of the things we worry about with the radiofrequency energy and open irrigation is that we give fluid to the patient, and that can kind of build up in patient body and lead to some time to pre-pulmonary edema, so kind of a wet lung, so to speak. And with this approach, we've seen that we give way less fluid to achieve to cover the same area. So clearly faster because we can drive better power, better lesion quality, but with lower fluid administration. So clearly for the patient and for us is a more effective and efficient procedure.